Is this thing on? All right. Good morning, everybody, or whoever is joining us on the recording. This is Unit 4, Trigonometry, which is dealing mainly with sine and cosine, and then the functions that we create from those ideas, from those two functions. So sine, you might know what it looks like in very simple terms. If you had a curve like this, and so on, it'd keep going in both directions. That's sine, that's the sine curve. And we'll talk about that a lot. The cosine curve looks almost exactly the same, but cosine starts here and then continues onward. So they're related but different. This shouldn't be new to you, which is why I'm not covering it in too much detail. But the reason I'm graphing them here is this unit, the whole point really is to be able to make the graphs and to interpret the graphs. So yeah, and the reason I mentioned that all the functions are related to sine and cosine is because every function is made from sine or cosine. So for example, if we want tan, you might already know that tan of some angle is really just the sine of that angle divided by the cosine of that angle. Or if we wanted cotan, which is kind of like the sister or brother function of tan, it's the flipped version. It's the cosine of whatever angle we're talking about divided by the sine of the angle that we're talking about. And finally, there's only two more. There's secant, or I should say there's cosecant, or cosecant, which is 1 over the sine of the angle. And then there is secant, which is 1 over the cosine of the angle. And there's a few ways that I remembered how to, distinguish which one's which. If you have cosecant, then it does not have cosine in it. You flip from C to S. And if it's secant, it doesn't have sine in it. So you don't have S on both sides. You'll have secant, and then it's 1 over cosine. Because a lot of students are like, how do I remember which one's secant? Well, it's either sine or cosine, 1 over sine or cosine. And it's not 1 over sine because then you'd have the two S's. We don't want S on either side. Okay, so that's just the quickest review I could. Some of you, I think, went ahead and did some of the early pages, even though I said not to. Nothing wrong with that, but we are skipping the first 14 pages. Who came in? Hi, Hazard. Nice to see you. And Tala, nice to see you too. So let's jump right to it. We're going to jump to the graphs of the 6 types of functions. So this is skipping to page 15. And for those of you who saw Tom's video, this is not new, but I'm starting to move more into starting the topics myself. Not because there's anything wrong with Tom's videos, but because the next few topics, really the practice is just that. It's more of the same. And these concepts, really, if I don't cover them sort of from the beginning myself, then I don't trust that you'll necessarily watch Tom's videos either. I want to make sure that everything's perfectly covered fully by me if I can help it. So I'll still assign Tom's videos to watch, but I guess what I'm trying to say is I'm going to be doing a lot of the same things that Tom is doing. So for some of you, that's really good. For others, it probably doesn't make much difference. Okay, so let's get to it. The graphs of the 6 functions, which I said earlier, and these up top, these are 4 different functions. It's assuming that you already know the graphs of sine and cosine, which we'll get to soon. But these are the functions of tan, cosecant, secant, and cotan. So let me just get right to it. You'll see that, for example, the graph of tan is this here, and you can see it's the blue, okay? So it kind of goes up and over and then up again, up and over and up again. It's a repeating function. It kind of does this forever in both directions. You'll notice that the biggest feature of the graph is that there's these asymptotes. So it asks the question, why are there asymptotes? And we covered asymptotes when we did the other unit 3. Well, in this case, there's asymptotes because of what tan is. So let's just get right to it. I'll come back to this domain and range stuff in a second. Tan of some angle x is the sine of that angle x over the cosine of that angle x. And because we have a function on bottom here, cosine, if that function is ever 0, you know, cosine of some angle, if you spit that out, so for example, if I put in cosine of 0 here, it gives 1. But if I put in cosine of, let's say, pi over 2, I know that that's 1. That should give 0. You might find this. So you might find it gives you some crazy number like this. If it does that, it means that you're in degree mode. So you do not want to be in degrees for this topic. And so you want to make sure that you go into radians mode, which is very simple. You'll just, on the Casio anyway, hit shift, setup, and 4, and make sure that you've got. Let me show you that exactly, because if you're not in radians mode, then you can't do most of what I want you to do. Okay. So for this whole unit, we're going to be dealing with radians. So on the Casio, you go shift mode, which is getting into setup mode. And you want to tap 4 for radians. So 4. And then you'll see up on the top here, it'll have a little r, which means when you put in things like pi, and pi is like the ultimate thing, you know you're in radians if you see pi. We've done that before. It'll give you 0 for this answer instead of some crazy 0.999999. What I mean is, if you were in degrees, this would give this number instead. It's not good. You want to make sure that you get 0. So that's kind of your quick test. All right, should give 0. So where was I? I was saying about cosine. Well, clearly, because of what I just showed you, clearly this function cosine of an angle can be 0 sometimes. So we can say there's asymptotes when cosine of the angle equals 0. When this bottom equals 0, when this equals 0. Of course, when you divide by 0, the function explodes. So there's no possible way that we could get a value out of that. And when is cosine x 0? Does anyone know what those numbers are? If you remember from maybe Math 1700, I think you would have covered which function values, which values, like which types of pi give cosine of 0. Does anyone know? Anybody? You alive out there? Okay, I'll tell you. I don't want to, kill you over here. But you can grab it from the graph. Look, let's just look at the graph. I'm just going to draw a line down here. What value is this? Well, this is pi over 2. So for example, we have pi over 2 is one of the values that we're not allowed to have. It's an asymptote. We would be dividing by 0. And then we have 3 pi over 2. And we have whatever this one is. Well, if it's 1 pi over 2 and 3 pi over 2, it's 5 pi over 2. And so on. And it goes in both directions. So let me just give you a rule for this. There are asymptotes whenever we have pi over 2 plus or minus n pi. So let me put this over here. Pi over 2 plus or minus pi. This n just means 1 or 2 or 3 or 4. So pi over 2 plus another pi. So if you add pi to it, you get 3 pi over 2, and 5 pi over 2, and so on. So let me show you what I mean. If we had, I won't do this every time, I'll just do it once. So look at this. Cosine of pi over 2. So you should try this yourself because you're going to need to be able to do this at some point. Pi over 2. Oops. Pi over 2 is 0. So that's going to give an asymptote because the cosine is on bottom. Let's go back in there and add pi. We add pi to this. It's also 0. So it'll give an asymptote if we divide it in the tan function. What about 2 pi? Another 0. What about 3 pi? Another 0. Okay, so we get this pattern, and then minus as well any of these subtractions work the same way. So pi over 2 minus pi, minus 2 pi, minus 3 pi, all gives 0. So that's why there's asymptotes here. But because of the way we're doing it in this course, you actually have an advantage. The only thing we're going to ask you to do in this course, we're not going to ask you to sketch these fancier functions. We're only going to get you to recognize them. So on a multiple choice, for example, you would just tell me which one is which one's tan, which one's cotan, and so on. So don't worry too much about it. You can always just graph it on Desmos, and it'll come up. It'll just show you what the graph is. Okay, so let me put this over here. That's our story for tan. So long story short, if you take sine divided by cosine, it'll give you this function. It always looks like that. And the asymptotes, where the function doesn't exist and where the graph tries to get to but can't quite touch, that's pi over 2, 3 pi over 2, and so on. But we can graph it. So let's look at this quickly. Let me bring up what you should be doing always when we're dealing with things like this. You should graph it. Just type in tan, save yourself some trouble. Okay, tan looks like this. If you want to be a little bit more specific, look at this. Tan is the function, if you want to know which one's which, tan is the function that goes right through the center and has this shape. It's really all you need. It goes the y-intercept is at 0, 0, 0, and it has that shape. It goes up and over like that. So we'll get to that more very soon. Okay, let me go through the others. So I'm not going to go through it quite as detailed. I'm just going to jump to it. Cotan. What does cotan look like? It looks exactly like tan, but the opposite. So instead of going up and over this way, up then a little bit to the right and up, it goes to the left instead. And that's because cotan of x is cosine over sine. And the asymptotes, I'm sure someone can tell me now. There's asymptotes when what? It's sine is going to give it to us because asymptotes come from when the bottom is 0. So if we divide by 0, that's when it explodes. So the asymptotes are when sine of x equals 0. And when do we get that? What are the values? You know, where's the first asymptote? It's at 0. Where's the second asymptote? It's at pi. The third asymptote is at 2 pi, 3 pi, or negative pi, negative 2 pi. So it's very simple, plus or minus n pi. And what that means, n is any natural number, which I think we've covered before. So for example, it could be 0, it could be pi, 2 pi, 3 pi, and so on, plus or minus any of those. Just try it yourself. You know, little experiment, 5-second activity. Take sine, put in any value of pi that has a constant in front of it. So 17 pi, a million pi, 2 pi, 1 pi. Sine of any number times pi, which is not a decimal. So I'm going to say 7. Sine of 7 pi, 0. So it's easy. Any whole number in front of pi will give it 0. Okay? Very important later. And we'll notice, look, the asymptotes are at 0, or 1 pi, or 2 pi, or negative pi, negative 2 pi. Let me just write this in. This is negative pi, negative 2 pi, negative 3 pi, are the asymptotes. Okay? For the same idea. Hopefully that's okay. There's not much to it yet, really. The secant and cosecant functions look different, but have the same basic idea. We'll see that secant is what? Does anyone remember what it is? Well, it's 1 over something, because the tan and cotan are sine over cosine in some combination. What about secant? It's 1 over what? I said it before. It's 1 over cosine, and you know it's cosine because you're not going to have two s's together. I mean, there's an S here, so it kind of changes to a C. And then we have asymptotes. When what happens? When cosine is 0. And cosine of x is 0. And we just covered that. We should know what those asymptotes are. We just talked about it. So I know it's early, but I'm trying to keep your brain on here. It's when we have what? Pi over 2 plus or minus any whole number times pi. So you can have pi over 2 plus or minus 3 pi, 4 pi, 5 pi. In easier terms, that's pi over 2, 3 pi over 2, 5 pi over 2, any odd number pi over 2. And you'll notice there's other asymptotes here. This asymptote here is y equals 1. This asymptote here is y equals -1. And it sort of keeps the function from touching. Okay, let me just cover cosecant, and I'm going to give you a few tricks to remember these. Cosecant, we have our same asymptotes, y equals 1, y equals -1. It looks almost exactly the same, so you need to make sure you know how to tell the difference, because again, it'll be a multiple choice of some sort, or you can graph it on Desmos. Cosecant is what? 1 over, well, there's a c in front, so it has to change to an s sign. Asymptotes. This is asymptotes when what? You should be getting really good at this, and this is the last one, so if you've got it by this point, you should have it. Asymptotes when, yep, when the bottom is 0. That's when the function explodes. So when sine of x equals 0. And when is sine of x equal to 0? Well, when we have even numbers of pi, plus or minus n pi. Thank you, Ali. 5 stars, 5 points to Gryffindor. So we have plus or minus n pi. And again, 1, 2, 3, 4, 5 pi, or any number in front of pi. And that's confirmed by this. We have 1 pi, 2 pi, negative pi, negative 2 pi, and so on. So how do we tell the difference between all of these? Well, I'm going to give you a little chart just to remember. And hopefully you won't need to worry about it. First things first, if you are in doubt in any form, just use Desmos. You know, even if you have the question in front of you and it asks you to pick out the graph, just graph all 4 on Desmos. Just put them all 4 of them into Desmos and see which one's which. But if you want a sort of cheat sheet, you know, one place to look at what's what, I can do that for you. So, what are all of our possible functions? Well, the functions, they could be tan of x, they could be secant of x, they could be cotan of x, and they can be cosecant of x. All right? You with me so far? Hopefully so. Tan x and secant x, if we want to talk about asymptotes, tan x and secant x both have the same asymptotes. It's pi over 2 plus or minus n pi. Or in other words, the asymptotes don't go through 0. Okay, if you graph it, you'll notice it doesn't cross the origin. For the other two, the co-functions, the cotan, the cosecant, their asymptotes are plus and minus n pi. And they go through 0. All right, so this is kind of your cheat sheet. This is all you really need to know. And there's one thing I always liked, I don't know, someone told me once upon a time, it always stuck. These functions, the ones that go through 0 are what I would call the easy asymptotes. And it's kind of silly. These are, I'll say, easy asymptotes. You can think of it as EC because it's easy, and the C functions are easy. Do you understand what I'm saying? The C functions are easy, EC. Easy. Because when you look at them, they go right through the center. There's no complication. Okay, it's stupid. I get it. Easy, you know, the word easy, easy, they're EC. Can't win them all. I'm a dad. I got my share of dad jokes, okay? So let's look back. Let me show you what I mean. Tan. Look at this function only, okay? I look at this and I'm like, hey, the function doesn't go through, the asymptote doesn't go through 0, so it's not an EC function, which means it's not a C function. So it's either tan or secant. And I know it's tan because tan looks like that. I'm done. Cotan. Well, this one must be, if you didn't know it was cotan, and you just, let me just clear it a bit. If you only saw this graph, you would be like, well, it's either tan or cotan, because tan and cotan look like this. It must be cotan because it goes through the center, and that the center is 0, so it's the EZ asymptote. C, EC, EZ, EC. No? No? Okay, let's say I gave you this one, and I said, what function is this? Well, you would be like, well, it's clearly not tan or cotan. Maybe it's secant or cosecant. Well, it must be secant because the asymptote doesn't go through 0. There's no asymptote here, so it's not an EC function. It's not EC. It's more difficult. Not EC, so it's not a C. And of course, no, it's not a C, it's an S, it's secant. Let's look at this one. Is this an EC function? Yes, it is, because you can see the asymptote goes right down through the center. If it's, that means it's a C function. So it's either cosecant or it's cotan. It must be cosecant, because this is what cosecant looks like. All right, so it's an EC function. One of the easy asymptotes, less complicated asymptotes, goes right through 0. And I call it easy because it's either 0, pi, 2 pi, 3 pi, no fractions. Okay, so hopefully that helps you. If it doesn't help you, just graph all of the Mundesnos and compare them. I'm just trying to give you some tools that you can use to do this fast, because there's only 4. All right, hopefully that's somewhat clear. Is there anything I can review before we move on to the rest of what I want to do today? I'll take that as a no. Of course, let me know at any time if it's not. For any of you that came in late, no, we didn't cover pages 1 through 14. We're not covering pages, well, 2 through 14, because that's what I had to skip for the Eid break, because we lost 3 full days, right? So we're just jumping, we started at page 15. Okay, so the graphs of sine and cosine. I really like this topic because it's quite easy, and students find it easy too. So hopefully you'll enjoy it. The rest of the course is not too difficult. There's a few spots here and there that are tricky, but I think personally that the hardest part of the course is behind us. So just a little bit to let you know. So the graphs of sine and cosine. It says important quantities of trigonometric graphs and the functions y equals a sine bc plus c, and y equals a cosine bx plus c. These are taking sine and cosine functions and just transforming them, sort of like we did before. You know, we can shift them sideways, we can shift them up and down, we can stretch them. Really, for the sine and cosine functions, we're going to do easy versions of that. So first of all, we're going to be dealing with amplitudes, which is how tall the function is. I'll show you pictures of this very soon. The period of the function, which is how long it takes to get from one peak to another peak, or one part of the function to the same part of the same function somewhere else. And then displacement is really phase shift or horizontal shift. And just take this, and you can use this as a reference. We're going to use this a lot later, okay? So there's formulas. These are things that we're going to actually put numbers into. A, 2 pi over b, and negative c over b. If you know those things, you're going to be perfectly fine, okay? So it says one thing we're going to want to keep in mind, we're dealing with radians here. And the rest of this I'm going to explain visually. You can read this, of course, but I want to explain it visually what it means. So let's just say we had our functions. Let's just look at this. This is our graph of sine. All right, this is a couple cycles or a couple repeats of the sine function. And hopefully what you'll notice here is it has an amplitude. I don't know if you've done this before, but the amplitude is how far we go from the center line in either direction. So in this case, the amplitude is 1. You could also go down, and the amplitude would still be 1 because it's just it's the absolute value. Let me make this more in line with the notes. So we have A is 1, or A is 1. Okay? Actually, I'll keep it A because that's actually even more in line with the notes. So the amplitude is how far you go from the center, okay? If we make it bigger, if we made amplitude 6, it would stretch up. So let me do that. If amplitude is bigger, so for example, sometimes this freaks out. I'm going to make amplitude a little bigger. Look, it just stretches it. So amplitude now is 3. And you should look at that graph and say, yeah, of course it's 3. Look, it's easy. It's from the center line. It goes up and down by 3. Done. If you don't see what I'm talking about, it's 3. If you go down from here, it's 3. So that's the amplitude. Done and dusted. What if we had amplitude back to 1? What does B do? Well, B, which is, again, I'm looking at this B. Sometimes this freaks out. Sorry about that. B is something that stretches the function sideways, horizontal stretch. Look at this. Right now, B is 1, so it's regular size. If I change B, look. If I make B really, 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 really big, look what happens. It's like I'm stuffing it into a little small space. I'm stretching it, or I'm compressing it like a spring. So if you've done physics, you push a spring in. If I want to release that spring, I make B smaller. So in a way, it's like making the spring constant smaller. Stretch it out. And you can actually make it really, really stretched out. Look, this is a small b, and this is a big B. Small b, big B. Small stretch or small compression, big compression. All right? That's what these ideas are. It'll come in helpful later when we work with this stuff. And then C, what does C do? Does anyone remember what C did? Well, C is displacement. So instead of stretching it or changing the shape, we just move it sideways. So if I move the displacement to the left, it shifts it that way. If I shift it back, I've shifted it back. Really, the function should start here. If I move C, just look where that y-intercept changes. What I'm talking about is, this is where sine should start, but if I have a C value, it just moves it. So it'll move it to the left or move it to the right. So for example, the C in this case is about pi. It would move it pi to the right. Okay, so in summary, let me put this back to normal here, no phase shift. Our value A has to do with amplitude, how tall it is. Our value B has to do with period, which is actually how far we are from, say, here, this is our period, from 2 points, same points on the graph, or from here to here. Or we could even, if you wanted to choose a different period, any 2 of the same points on the graph. Can someone annotate and show me maybe what they think? Take a point and then show me the same point on the same graph somewhere else. Someone just take a point on the graph. So for example, I'll give you a point. Look, someone tell me, based on this point, where's the same point on the graph somewhere else? You know how to use those annotation tools? You can draw on my screen. Just go into participants, click annotations. No? Whoa! Nice, nice. This is perfectly right. So this would be another period. It's where this function starts and starts again. The reason why it's correct is from this point here, I go down and then hit a curve. From, I'm not sure who drew this, but they go down and come up. So yeah, of course, this function starts again there. A lot of students put a value here. They say, hey, it must start again there. It's the same point. Well, that's not right, because in the beginning it went down, and from here it goes up. So it's actually not restarting yet. Anyway, this should be review, so I'm not gonna beat you over the head with it anymore. Let's go and do the math, which I find is quite simple actually. So amplitude has to do with, you know, if this is our function, this would be amplitude. Our period would be from one point to another point. Should probably keep going. It could even be from here to there. Oh, that was a terrible example. From here to here. You get the idea. And then our displacement is if it was moved sideways, which in this case, it's not moved sideways, okay? Let me give you another couple notes. Amplitude is kind of like height. Let me just read and see what it says. 1/2 of the vertical distance from the minimum to a maximum. So half the distance from the top peak to the lowest peak. Since we only consider curves that are centered on the x-axis, the amplitude is the greatest y value. So just find the top of the curve. The same thing I said. Period is the length of one cycle, and the horizontal distance from one max or minimum to the next max or minimum. It's the same thing I said. And then displacement shift, the amount the graph shifts to the left or right from its original position. It's usually determined by the movement of the original y-intercept. So if the y-intercept moved from 0, 0 over, then we've got a new thing. We'll deal with that as it comes. Let's do some examples. And again, Tom talked through these, but I'm going to be doing a lot of the same ones. These are the basic sine and cosine curves. Let me just point out a few interesting pieces. When x equals 0, sine is 0. When we have pi over 2, y is 1. When we have pi, y is 0. When we have 3 pi over 2, y is -1. And then when we have 2 pi, it's 0 again. So we can build our sine curve based on those 5 points. But let me just note them. For sine, this is our 0 point, our maximum, our 0 point, our minimum, and our 0 point again. For our cosine, we have slightly different points. Look at this. I'm just looking for the easiest ones. This is all that really matters. So when we start for cosine, cosine starts at a peak and comes down. That's how it starts its story. Sine starts at 0 and goes up. So let me show you this on the graph. Cosine starts at 1, comes down to 0 when pi is pi over 2, when x is pi over 2, goes to -1, comes back up to 0, and then goes back up to the top. So cosine and sine basically have the exact same story. They're just shifted by pi over 2. You're going to notice that sine x and cosine x are the same graph, just shifted, phase shift or displacement, by pi over 2. All right, what do I mean by pi over 2? Well, I mean that if I was looking at, say, this point here on the sine curve, if I was just to push that back a little bit by pi over 2, it would become the cosine curve. So hopefully that makes some sort of sense. Most of this you don't have to like do from scratch. The numbers will help you get the answers. So I'm just trying to give you the big picture. I don't know how much you know about this stuff already, and so I'm trying to help you through it. All right, so the most important points usually are 0, pi over 2, pi, 3 pi over 2, and 2 pi for the standard curves. Okay, let me get to the actual math stuff, because this is still set up. This is something I mentioned before. From the above, you should note that the shape is the same. The only difference is the horizontal shift is pi over 2. And I've put a star here. You should make a note of this. For the basic sine and cosine curves, the amplitude is 1, period is 2, displacement 0. Okay? And finally, these are the two types of curves we're going to be dealing with. Let's actually start filling in what the values of A, B, and C are, so you can see how all this fits together. Because I've talked a lot, but I haven't actually had you do anything yet, which I hate, but it's just the nature of the introduction. Let's do something. Again, Tom did this, but I think it's important to do it again together. The effect of A. A is height. So you can think of it as a sort of height. It's not really height, but I guess I should say it's height or really vertical stretch. So let's look at this. We have y equals 3 sine theta. It looks like this. From the graph, can we figure out what amplitude is, period is, and displacement is? Well, we have a formula for amplitude. Amplitude is the absolute value of A. And if we look at the graph, we can find A. It's whatever this height is. What's this height? Should be easy to find. It's 3. So right away I can say A is 3. While we're looking at this, maybe we could figure out B and C. Can we figure out B? What's B? B is the what? Does anyone know what B is? If you're not sure, I'll give you a hint. Let me color code this. A is the number in front. B is the number in front of the X. C is the number after the X, which in this case we don't see. B actually is not period. B gives us period. So, well, thank you very much. Oh, this got me coffee. Best day ever. Okay, so B is not period. B is related to the period. We steal it from the equation. So what number is hiding in front of this X here? It's 1. It's not actually, you can't see it, but it's 1. And then C, we don't have C. So we can say that C is just 0. Okay, so let me color code it one more time. A is 3. C is 0. B is 1. I'm going to just keep the highlight and change these back to black. Okay. All right, and that's actually going to be the basis of almost everything we do today. We're dealing with A, B's, and C's and manipulating them. Okay, so I'm going to go through this quick and we'll do another one. So amplitude here is the absolute value of A. So just take the positive version of A. It's just 3. What that means, it'll be stretched. We're going to have a stretch. It used to be at 1. It's been stretched to 3. Period. Well, the formula for period, if you don't remember, I've put it here, okay? I put the values here. I copied them. Period is 2 pi over B. So 2 pi over B. B is 1. So the answer, the period must be 2 pi. The period then hasn't changed. The displacement is negative C over B. So that's negative 0 over, what's B? Let's not lose track. It's not period, it's B, which is written above, which is 1. That means it's 0. Okay, so we have everything we need. Amplitude is 3, period is 2 pi, displacement is 0. Pretty boring functions, really. They're pretty boring answers. But our graph kind of confirms this for us. we can see that the amplitude is indeed 3. I got that right from the beginning. The period, just allow me to zoom in here for just a second. I want to take any 2 points on the graph. Well, the easiest ones to take would be right here. Let's take this point. Where do we see this again? It would be when it goes up, goes down, and starts again, so it's right here. That distance is definitely 2 pi. We can see the period is definitely 2 pi, and our math confirmed it. And what about c? Well, if we look at the x-intercept, if I make it here, you know, in the center here, the x-intercept, or sorry, y-intercept hasn't changed. It hasn't been shifted. And so it's okay. Our numbers are fine. Hopefully that makes some sense. Let's do another one. You know, let's right away, give me A, B, and C. Type it in the chat. A equals, B equals, C equals. What do we got? A is going once, going twice, going 3 times. 1 over 2. Yep. B is the number in front of x. There is no number in front of x, so it must be 1. C, what number is it? Is it been shifted? Is there a plus or a minus at the end of this thing? No, there's not. Well, there's a 0. And once again, that's all we need. Let's see if our numbers will give us back this graph. Okay, amplitude must be 1 over 2. Period is 2 pi over b. So once again, 2 pi over 1, which is just 2 pi. Period hasn't changed. Displacements, once again, negative c over 1. So it hasn't changed either. Nothing's been done. The only thing that changed is the amplitude. So it got squished down. So let's just make that. That would be the same as if I went from 1 to a half. And c is 0. There we go. Squished. No problem. The previous one was this. It's just the same function being squished. All right? So this is the big idea. And again, if you're a little bit lost, the number in front is always your a. The b value is always whatever's in front of the x. And your c value is whatever comes after that x, plus or minus something. And in this case, we don't have anything, so it's just 0. And all this really told us was that we had a compressed graph. Okay, so we're starting simple. Let's try some more tricky ones. If you need me to go back, let me know. Let's see, the effect of the value of b. Okay. B controls the period of the curve. B constant controls the period. Let's do this. A is what? What's A? Whatever's in front of this. 1, good. B, what's B? The number in front of x, 2. What's C? It's the number after x. It must be 0. So this just gives 1. This is 2 pi over b, which is 2. That would cancel these two. Gives us pi. Ooh, our period is now smaller. It used to be 2 pi, now it's pi. So it must have been compressed. And displacement, same thing, 0. These are done. This is all we need for these answers. And I'm going to check this. Okay, sir, do not understand how to get the period. So Ibrahim, very simply, I'll try to make it simple. It's just this formula. So it's always 2 pi over b. All you need to do is find b, and you put it into the formula. Okay, I'm glad you got it. Okay. These are our formulas, just in case you missed that. And they're written earlier in this section. Okay, I'm going to go on Desmos real quick just to show you that this is true. So sine of 2x. So a is 1, period pi, displacement 0. So a is 1. In this case, b was what? B was 2. So 1, 2, 0. If I make this 2, look what happens. Squish, 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 squish. Squish, 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 squish. It's squished in. It compressed. This is exactly what I'm looking for. The period went from 2 pi to 1 pi. And we can confirm that on the graph. Look at this. Pi to 0. That's the period. 1 full cycle. So our period is now half as big as it used to be. So this is exactly what I expected. And same thing here. All right, let's keep going, shall we? I guess I should mention something too, and something I've been talking about but hadn't said specifically. If the number b is bigger than 1, the period will decrease. If the number b is smaller than 1, the period will increase. So for really big b values, think of it as a really big compression. For a really small b value, it's a really small compression. So it actually makes it bigger. Okay, let's take a look at what that means. Okay, very fast. Let's do it. A, 1. B, 1/2. C, 0. That means amplitude is 1. This is 2 pi over 1/2. Now I'm going to help you figure this one out because some of you are really, really bad at fractions. My best advice would be to use your calculator and have that help you. You can even ignore the pi, but for now I'll include it. So set up a fraction and say 2 pi. And then what I'd recommend is on the bottom, set up another fraction. 1 over 2. So the answer is 4 pi. Let me write that in. I'll fix it later. Okay, 4 pi. If you don't want to include the pi, you don't need to. It doesn't change anything. You can just add pi to the answer. So I would say 2 divided by 1 over 2. It'll still give 4. Just put pi next to it when you finish. Some of you don't have this calculator, so you can do it normally. I'll just go 2 divided by, and then on bottom, use brackets to show that it's the full fraction. So you'd go divided by 1 divided by 2. Okay, so you should hopefully see that it's 2 divided by 1/2, or 2 divided by 0.5, which is still 4. So we have our 4, all right? So hopefully that's, helps you a little bit with the fraction stuff. Let me just clear this up. So 4 pi. And then displacements. What's displacement? Displacement has the formula of negative c over b, just in case you're forgetting. So that's negative 0 over 1/2. Doesn't matter what you divide 0 by, it's going to be 0. So it's 0. Okay, you all with me so far? Easy peasy? Lemon squeezy? Okay. We'll work on C in a second, but let's just quickly look and see if this makes sense. Is the amplitude 1? If I look at this graph, is the amplitude 1? Well, yeah, for sure. Looking at it, I can see that it goes to 1. So my answers are okay. The reason I'm mentioning this is that if you didn't have the graph, you should just take this and put it into Desmos and see if it gives you the same thing, okay? The period, 4 pi, is it 4 pi? Well, I'll take any 2 points. Let's just say, take this point and the top point. The distance is 4 pi. So yeah, my answer is definitely right. Because a different point. From here to here, it's supposed to say 5 pi. From 1 pi to 5 pi, the difference is 4 pi. So the period is definitely 4 pi. And finally, the displacement. Has this function been shifted from the center? Well, it looks like no. I'll say there's no displacement because cosine x has its original y-intercept at 0, 0. So it hasn't moved. 0, 1. Cosine already, your regular cosine function, this is a cosine function, all cosine functions start at a peak. So cosine starts on a hill and then goes down. Sine starts at 0. So you'll notice, your regular cosine functions, let me draw it over here. Your regular cosine functions always start like this. So it hasn't moved. There hasn't been a displacement. Just like up here with sine, all sine functions are supposed to start like this. And that y-intercept hasn't moved, and so the displacement hasn't changed. It hasn't been shifted left or right, I guess is my point. Okay. But most of the time, you just need to deal with the numbers. But some of you like to know what the numbers mean. You all should, but some of you like to know more than others. Let me make a few notes, and then I'll move on. In this case, the period, did it increase or decrease? For the first example, example 2a, did this period increase or decrease? Well, it used to be 2 pi, so now it's pi, it decreased, got smaller. And then over here, 4 pi, did the period increase or decrease? Well, it's supposed to start at 2 pi, it's now 4 pi, so it increased, it got bigger. Which means it's same idea as being stretched out. I don't care which way you explain it as long as you understand generally what's going on. Okay, so any questions on that before we try the next few questions? All right. I think that once you see where we're going with this and how far we're going, which isn't that far, you'll find that this is actually pretty easy stuff. I hope so anyway. I hope you find it easy. I hate it when the courses are difficult and everyone gets stressed out. I just want everyone to have a good time. Everybody relax. You know, take 10 minutes between each class, play some video games. Okay, let's move on. The value of C. And remember, C is this guy. And it's the phase angle, also known as the displacement, also known as the horizontal shift, also known as phase shift. It has like 3 different names. They all 4 different names: phase angle, phase shift, displacement, horizontal translation, horizontal shift. They all mean the same thing. It means it's been moved sideways, right? I can explain it all without words. Look, this is what C does. Okay, that's what C does. Moves our function left and right, right? That's all it does. It's literally everything that it does. So to be crystal clear, if C is positive, the graph will be moved to the left. If C is negative, the graph will be moved to the right. That's nothing new. That's our same, if something is affecting the x values, you got to do the opposite thing, like we did last unit. So hopefully it makes some sort of sense. Let's pick it out. And I'll try this, let's try this question here. What do we got? A is, B is, C is. A is 1. What's B and C? These 2. C is 5/4. All right, so there's not much to it. Occasionally they'll be slightly trickier, but this one's not tricky. You can just match it up. I'll make it clear for you. A is 1. So for those of you that aren't sure, that's where that 1 comes from. Our B, again, is the number in front of the x. And our C is the number after that. This is the first time we've actually had one to work with. And so it makes things a little bit more complicated, but not by much. What does the B do? If we have a B of 2, 3, 4, 5, I like to think of this as a squish. You know what a squish means when you squish something? Or compression. It's not stretched, is I guess what I mean. C, if it has a positive pi/4, it means it's been shifted left. Because it was positive. Okay? So let's actually answer the question. What's our amplitude? 1. 2 pi over b. Well, 2 pi over 2, because b is 2. They cancel. We get period of period of pi. It used to be 2 pi, now it's pi, so definitely got squished. Displacement, what's our formula for displacement? Well, let's see, negative half pi, let's see. Negative c over b, negative pi over 4 divided by 2. So this one's tricky. I'm not entirely sure it's a half pi. I'm going to confirm it on my calculator because I want the calculator to speak for me. Because I want you to be able to do this as well. Let's see, set up my fraction, negative, set up another fraction, other fractions on top, negative pi over 4, all divided by 2. Negative 1 over 8 pi. If you don't have the pi button on your calculator, or it doesn't make it so easy, just put 1 there in place. Negative 1 over 8. So this is negative 1 over 8 pi, or negative pi over 8. Okay, so Ibrahim, I just want to make a note here. We have pi over 4 over 2. So another way you could do this is to think of it this way. Yeah, it's okay, a lot of students make that mistake. I just want to bring it up. Just keep pi over 4 together, and it's divided by 2. So remember, once upon a time, division is actually the same thing as multiply by the reciprocal. Does anyone remember that? Hopefully you do. Let's just take negative pi over 4, and instead of dividing by 2, let's multiply by 1 over 2. Or let me make it clear. If we're dividing this by 2, it's the same thing. Sorry, my pen is, need my pen to come back to life here. It's the same thing as pi over 4 multiplied by 1 over 2. They're the same thing. They mean the exact same thing. And then hopefully you can see, if you multiply the tops, it's negative pi. If you multiply the bottoms, it's 8. So a lot of students have trouble with that, and they don't trust the calculator and so on. Just be careful. If we have fractions, you can almost always change it into a multiply to make your life easier. But in any case, this is what we got. And I think that's good. I think that's pretty much all we were looking for here. Yeah, this is all I can really see. So let's just check our graph and see if it makes sense. Does our amplitude make sense? Well, the distance from here to here is definitely 1. So, yep, amplitude is 1 is okay. Period, pi. Take 2 of the same points. So for example, the peaks, and see if they're the same. Let's see. Period. I'm going to take this point and this point. Actually, that's tricky. Let me try to take an easy point here. I'm actually going to take this and this. The reason I took that is because I know this is 0. I know this is pi. So the period is definitely pi. So the distance from one point on the graph to the same point somewhere else on the graph, I'm trying to stay in the lens here, is pi. The distance is pi. And the displacement, I want to make sure you understand what that means. The displacement here, let me put a little note. For the sine function, the sine function is supposed to start here. Let me make this more clear. For your regular sine function, if it looked like this is your regular sine function. The y-intercept is supposed to be here. But in this case, the y-intercept has been moved sideways. It's been moved left by this little amount. That little amount is negative pi over 8. some shifted left. So it's like if we take that whole function and just shift it to the left by pi over 8, that's what we get. And we can see it's halfway between pi over 4 and 0, so it definitely is pi over 8. Let me show it on Desmos. It's a little more clear sometimes. Okay, so our original function is, let me just type it in. This is our function if it hasn't moved. See this? Where's pi over 8? Where's pi over 8 when I need it? Anyway, big deal. That's our original sine function. And you can see that I'm not just lying to you. It does indeed have a y-intercept at 0. The original function has a y-intercept at 0. I want this to be pi over 8. And let's see, it should shift over. Let's see if I can make it work. I want c to be negative pi over 8. Wait, is c negative pi over 8 or pi over 8? Oh, c was pi over 4. Yeah. So let me just annotate the screen. This is where it ends up. Negative pi over, wait a second, negative pi over 4. Oh, sorry. I don't mean to confuse you. I didn't put in my b value properly. 2. So, okay. It's been shifted over, negative pi over 8. And it used to be here. Okay, sorry, that wasn't as clean and perfect as I wanted it to be, but who's clean and perfect all the time, you know? So this is our original function. If we choose to shift it, so for example, in our question we were given, it was shifted by pi over 4. If I put pi over 4 in, it shifts that original function over to a new position. This is what it means. So hopefully that makes sense. I didn't mean to confuse anybody with that. I didn't explain it as well as I wanted to, but I think it's still okay. Any questions on that before I move on from this screen? Is anyone still awake? Copy's good for that. Okay, sorry. I don't mean to bore you to death or anything. Not my intention. I'd like to do some of the practice. Let's see. So I'll pick some good ones here. All right, I'd like you to try 1 and 2, and I'll do 4 with you. I'll also do 3 with you. I'd like you to try it. I want you to just get amplitude, period, and displacement. And if you want to know what the formulas are, they're over here. So take, just 3 or 4 minutes and tell me what the amplitude, period, and displacement are for these. And I'll jump back in at maybe 8, I'll be back 8:42. Okay, I'll wait just another minute or so, and then I'll start going through this. Okay, nice to see some answers rolling in here. You can try working on this, or I won't work on all of them, but I'll give you the basics. So let's see. 2 is, let's say, 1, 2, 4 pi, pi over 2, 3. So Ali, your answer for 3 for displacement, I think actually, no, you're okay. I've got an answer wrong in my answer key. So it looks okay. 4 is A is 2, period is pi, D is 0. Correct. For 2 sine 2x. Very close, Kevin. The question adds a little spin, which it says it was reflected through the x-axis. That's like the challenge portion. Do you remember what it means to be reflected through the x-axis? What does it do? And it changes the y values to a negative. So you should have a negative pop out of that. I'm just going to quickly write these out. For 1, A is 1, B is 1, C is negative pi over 6. So the amplitude should be 1, the period should be 2 pi, and the displacement should end up being pi over 6. I'm not going to do all the workings for that. You can do that yourself. But I'm just giving you the basic answers here for those who actually gave it a shot. The method is the same as what I did before. For this one, A is 1 over 2, B is 1, C is positive pi over 6. I'm not sure why it's all pi over 6, but that's okay. The amplitude here is going to be 1/2. That one's easy. The period here is going to be 2 pi, also very easy. The displacement here is going to be negative pi over 6. Again, probably a little bit too easy, but that's okay. There's nothing wrong with easy questions if it's helping you to understand it. A here is 1 over 2. B is also 1 over 2. C here, negative pi over 4. So this one I will do. Let's see. Amplitude is just 1/2. Period. Let's just be careful here. Period is 2 pi over b, which is 2 pi over 1/2. That's the same as 2 pi divided by 1/2, which is the same as 2 pi multiplied by 2 over 1. or 2, which is the same as 4 pi. And then the displacement is negative c over b, which means it's actually negative pi over 4. So it's positive pi over 4 over b, which is 1/2. So that one's a little bit tricky. You should be able to get this. If you're careful, it should be pi over 2. 1 over 4 and 1 over 2. If you're not sure, let me just show you. It's the same as 1 over 4 divided by 1 over 2, which is then the same as 1 over 2 multiplied by 2 over 1, which is 2 over 4, which is 1 over 2. Let me move this over. Okay, so what I did there, I took the 1 over 2 and sort of transformed it into 2 over 1 by doing the multiply by the reciprocal. Of course, you can always put it in your calculator. I'm just trying to give you skills that you can use to do this a little bit differently, or do it by hand instead of relying on your calculator for every single thing. Okay, so hopefully that's clear. These are basically the same as what we did before. 4, I'm just moving on to 4, if that's okay. Let me just finish off this. And these are really our final answers here. Okay, 4 I find interesting. That would be a little bit more of a challenge question. There's nothing wrong with the question. I could easily ask it on a test or something like that. It says, give the equation of the graph with an amplitude of 2, not A, but amplitude of 2. So we can say that the amplitude is 2. Period is pi. Okay, so period is pi. No phase shift, which means that the displacement is 0. That means that c is 0. And it's reflected through the x-axis. Okay, I'll deal with that in a second. If amplitude is 2, what do we know? Well, we know that the amplitude relates to the a value. So that gives us a equals 2 directly. If period is pi, this is something that we're going to deal with a lot later. If period is pi, we know that period is 2 pi over b. So 2 pi over b is our pi. Hopefully that's sinking in. This is our formula. 2 pi over b is pi. That means that b must be 2 pi over pi or 2. You can just cross multiply that. Right? You cross multiply, you can consider it as pi over 1, so 2 pi times 1, switch those positions, whatever way you need to do it. You need to be able to be doing this algebra stuff by this point. The b is 2. If displacement is 0, it doesn't matter that it's negative c over b, really. So we can write it anyways. C is got to be 0. If there's no displacement, there's no phase shift. There's no c in the story. Some students ended this here. They thought that this was the full question, but be careful. It says give the equation of the graph. So let's remember that our equation has a standard form. And let's just fill it in. So if this is true, then y is 2 sine bx, b in this case is 2, plus c. Well, there is no c, so we can just close the brackets. That is the answer that Kevin gave me. The problem is I haven't used this little bit of information. Reflected through the x-axis. So if you want to reflect in x-axis, you need to do something special. You have to have negative y. Y becomes negative y. Or in other words, change all the signs. So we get a minus in front. Let me just shift this over a little bit. We add a 2. We add a negative. That's a little bit of a challenge there. So I'm going to put that as a slight challenge question, put a little star by it. But nothing that I don't think you can handle. This could also be a cosine function, honestly, because everything's the same. Yeah, Kevin, you came close. You got 3 out of 4 marks. So that's not bad. Maybe even more, maybe 4 out of 5 marks. Let's say, or y equals negative 2 cosine 2x. Because it doesn't say if it's sine or cosine, so as long as you have one of these two, you're fine. Is there anything I can clarify for that? Really, I just want to do a little bit more practice, because there's a few different types of questions on these. Okay. I've actually covered a lot more than I thought I was going to in this amount of time. I'm just looking ahead to see. The negative is before both, Kevin, because what it says is that the graph, it has the amplitude, the period, phase shift, and it's reflected about the x. If it says that it's reflected about the x, then it doesn't matter if it's sine or cosine. It's got to have that negative in front of it. The reason I started with sine is that's the simplest way to get it. Sine is the easier formula to use, but you could easily either one. It makes no difference. Okay, so the next page is practice. I'm not sure who just came in, but welcome. Who is it? Can I figure it out? Aisha? Okay. Bye, Aisha. So practice 2. You can see that it's it's more of the same. And so this is why I was wondering maybe I could just move on to the next topic here, or at least introduce it. It says in the following, determine the amplitude, the period, and the displacement of the given function. So really, it's a 3-step process that we've been talking about the entire day. You find A, B, and C, and then you use them to find amplitude, period, and displacement. So I'm just going to take a look at what we have here and see. Okay, I'll do a few of these in a second. I forgot about a little activity that I made. I want to just review the very first thing we did today. Let's just say that this was a quiz or a test, hint, hint, nudge, nudge, let's just say this is a question that came on a previous test, and we needed to tell this testing person, or me, what this function is. So what is this function? We only have 4 choices. It's clearly not sine or cosine. We know what they look like now. So it's either tan, let me make this smaller. It's either tan x, cotan x, cosecant x, or secant x. So which one is it? Do you want me to talk it through, or you want to guess first? Well, you shouldn't guess. It's not easy, right? It's not easy, which means it's not cotan or cosecant. It's not easy. Yeah? So it's tan or secant. Good job, Ali. It's tan or secant. Which one is it? Well, tan looks like almost like this crazy cubic function. Like it goes up. It's this line. Secant and cosecant are the ones that look like these curves, these kind of like weird looking cup things. So it's secant. It's got to be secant. So the function is secant. And if you want to confirm it, let me just see if it's secant. That's tan. So I think we're looking pretty good. Let me type them all out. Tan, cotan, secant, cosecant. Is it secant? Is it secant? Yes, it's secant. Look, I can see right at the center. It looks like this. It doesn't matter. Don't worry about the scale. You can stretch it whatever way you want, yeah? But it looks the same, and it doesn't have an asymptote through the center, so it's not EC. It's not a C function, and it looks like a secant. So you got that one. What about this one? Actually, this is the same one. I gave the same one twice by accident. What about this? Same story. It's either tan x. It's either tan x or secant x or cotan x or cosecant x. Is it an EC function? Yes, it is. So it's not going to be one of these. It's one of these. And tan has the line shape. So it's got to be cotan. So Ali, you got that one. It's not cosecant. Cosecant looks like those cups, those half cups. And if you want to check it yourself, you know, just play around with this until you find the one that looks the same. Is it cotan? Yep, it's certainly cotan. So you don't need Desmos, but if you want to use Desmos, it's there for you. Let's do one more. Which trig function is shown in the graph below? Well, it's either tan. Well, let's narrow it down. It's either tan or cotan, because they're the ones that look like this. And which one's which? Is it one of the easy ones? Or is it one of the not easy ones? Well, there's no asymptote there, so it's not easy. Must be tan. I'll confirm it. Is it tan? It's either tan or cotan. Tan looks like this. Or sorry, cotan looks like this. It has an asymptote right down the center. It's one of the easy ones. All the asymptotes are at pi, 2 pi, 3 pi, and 0. Tan looks like this. All right, so you don't actually need Desmos to do these. You can do them without a calculator, without a graphing calculator. Okay, any questions on that one? Hopefully you've mastered that now. I took these straight from old tests. So you can see that this question that I give you is not necessarily difficult. Maybe I'd give you two. Maybe just one. I don't know. Maybe one cup type and one line type. We'll see. I haven't made the assignment yet. Speaking of the assignment, I'd like to remind you that the assignment is not tomorrow. I thought that maybe that was a little bit too quick, and I wouldn't have been able to put very much on it. And I'd rather put more on it, or sorry, cover more different types of questions. It doesn't need to be more difficult. So the assignment's Tuesday, not tomorrow, not Monday. All right, so you get a day to relax, chill out, right? You'll see that this actually is it's not a real difficult unit, especially because I cut out the most difficult stuff. So you're welcome. Let's take a look at the practice. I want you to try 2, and then, you know, if we have some more time, I'll go and try some of the other questions as well. But I want you to try 2. I'll do the first one for you, and then I'd like you to do B and C, okay? So let's take a look. In each of the following, write the sinusoidal function. Just means sine x, cosine x. Sinusoidal that's just another way of saying sine functions and cosine functions. With the given properties in terms of sine x. Okay, well, it's going to be a sine function clearly. So we're looking for something that looks like this. A sine of bx plus c. That's the form that we're looking for. Let me make it more clear. Okay. Sorry. Okay. Amplitude of 4, period of 3 pi, phase shift of pi over 4. So again, these are not A, B, and C. These are things that help us get A, B, and C. And Ibrahim, I just saw your question, sorry. The assignment is about today and tomorrow's work. So the assignment will cover all of Unit 4, everything that we'll cover. Tomorrow's stuff is not actually that long. It's just kind of one big idea, maybe 2 big ideas. Just like today is really just 2 big ideas. All right? And the classes in math are at the end of the day, so you should have the day to study too if you need it. All right, let's do this. Let's see here, amplitude. I'll go up here. If we're given, amplitude of 4, we know that's easy. That means A is 4, nothing to it. The amplitude, we know that, sorry, the period. We know that period is 2 pi over b. If you forget that, write it out somewhere so that you remember it. We know that the period 2 pi over b is equal to 3 pi. You hate it. What do you hate about it, specifically, besides everything? We have enough time that I can help you with specifics. Is there like one part in specific that's not so clear to you? No, everything. Okay. Well, remember, I have office hours every day. Not one student has ever taken me up on it, but there's an hour every single day that I just make sure that I'm available to give one-on-one help. So, make sure you take a look at my schedule and take advantage of that if you need to. Okay, so let's go ahead and solve for b. We want b. We know that 2 pi is 3 pi. Sorry. We know that this is true. Let's just multiply both sides by b, divide both sides by 3 pi. That means b is 2 pi divided by 3 pi, which means it's 2 over 3. So Ali, you got that one. B is 2 over 3. Finally, phase shift. Let's just make it green, just so that it's all split up. Phase shift. What's our formula for phase shift? Well, if you don't remember it, go back and use the formula sheet. Phase shift is negative c over b. And we've been given pi over 3 as our phase shift. So we need to solve for b. Sorry, we need to solve for c because we already have b. Let's fill in what we have. Negative c over b is 2 over 3 equals pi over 3. So this one's a little bit ugly, not going to lie. Let me try and piece this together for you. That means negative c. I'm going to multiply both sides by 2 over 3. So I regret using the pencil, but it's okay. All right. I'm just multiplying both sides by 2 over 3. No, I'm not going to keep that there, but I'm multiplying both sides by 2 over 3. If you simplify that and bring the negative over, it looks like I get 2 pi over 6. Man, there's not enough space given for this. Or sorry, 2 pi over 9. Maybe negative 2 pi over 9. Okay, so I don't know why they thought it was a good idea to give that little space, but we just work with what we've been given. Now we've got our 3 important pieces of information. Why did I, or how did I know that I needed to do that in the first place? Well, in the very beginning of the question, it said write the function. And I can't write the function unless I know A, B, and C. Those are actually the only pieces I need. So I need to work backwards and get them, all right? So hopefully that makes a bit of sense. There's not enough space given to you, obviously. So let's see here. Y must be, let me just color code this a little bit better. So when you look back, you see something pretty. So we have 4 sine bx plus c. So that's 2 over 3 x plus c. Well, c is negative, so it's actually going to end up being minus 2 pi over 9. And that's how these questions are done. All right, so that's a function that if we were to graph it, it would have an amplitude of 4. It would have a period of 3 pi, which means from peak to peak, it would be 3 pi would be the distance, and it's been shifted back by pi over 3. Just as a final demonstration, I want to show you that this is, let me get rid of this stuff. You can build the function now. So let me just say y equals 4 sine 2 over 3 x minus 2 pi over 9. And let me see if the function is exactly what I said it was going to be. Let me annotate it. Is the, oh my goodness, what have I done? Okay. Just bear with me. Okay. Come on, annotation, don't let me down. 4. Well, is the amplitude 4 of our function that we built? Yes, it is. It's 4 tau, and 4 is the minimum as well. What about our b? Is the period 3 pi? From peak to peak, is it 3 pi? Is this distance to this distance 3 pi? Yes, it is. Now again, some students are like, what the hell is pi? Pi is just a number like anything else, right? It's just 3.141592. Sorry, I'll get to that, Ibrahim. Pi is just a number, so it's just 3.14 times 3. So this distance is 3 pi, which is the period. So my formula here is matching this graph. Let me finish off my little discussion here. We want to look at the phase shift. So this is a sine function. It took this original y-intercept and it shifted it to the right. And so we have what we expect. If the c is negative, then it's been shifted to the right. And I won't get into that, but we can see that it has been phase shifted. So all the pieces that we wanted are there. So to answer your question, Ibrahim, I didn't make it negative. You're talking about the negative here. There's no negative there because it hasn't been reflected. There's no reflection in this question. The other question earlier was a special case where there was a reflection. It was like an addition, it was a challenge at the end of the question. This question doesn't have reflections, and most of them won't. So let me show you. In the previous question, it says reflected through the x-axis. We don't have that condition on this question. So we don't have a negative. Yeah. Okay. Let's see if there's anything else. I think we've honestly done enough practice. I'm going to leave this 1 to E for you to do some other time, before the quiz or test, because all the solutions will be online, and honestly, they're all done the same way. I just want to do one other quick question, then we'll finish for the day. C is a little bit of a challenge question. I'll quickly do 3 and 4, actually. So this is a bit of a challenge, but this one's not so bad. So let me just quickly go through 3. Express the function in terms of cosine. So in terms of cosine, the trick here, cosine is sine x with a phase shift of negative pi over 2. And that was said there earlier. So let me show you how this works. We just take our original function. I'm actually I'll rewrite it here. This function here can be rewritten. You'll see that it kind of has this fraction on bottom, which is a little bit ugly. So let's just take each term separately. Take 2x divided by 4, that simplifies to x over 2, minus pi over 4. And now we can see that it has our form. It has our a, our b, and then our c. So sometimes you need to simplify first. if it has a denominator on bottom of all of it, just make sure you divide everything by that first. So now that's into our nice form, let me show you. I've said cosine is just sine with a phase shift. So watch carefully. I'll say y is cosine, I'm going to keep a, b, and c the same, of pi over 2 minus pi over 4. And I'm just going to add in a little phase shift, just a sneaky little phase shift here. And then it's now a cosine function. So let me write out my final answer. If you simplify that, put it in your calculator, negative pi over 4 minus pi over 2, you'll get negative 3 pi over 4. So that's a little bit of a challenge question, but it's honestly not too difficult. Maybe it would be a nice bonus question. It could be a regular question. I'm not saying it would be a bonus, but it's just different. So long story short, if you're given a sine function and you want to make it into a cosine function, all you do is add the phase angle at the end. You just shift the function a little bit over, and now it's a cosine, because they have the exact same shape. Okay, let me do 4, and this one's really fast. For the function y equals 2 cosine x over 2 minus pi over 5, what is the phase angle? Phase angle is another word for what? What's another word for phase angle? You've got like 100. It's called phase shift. It's called horizontal shift, horizontal translation, all sorts of stuff, but really just look for displacement. So the displacement is negative c over b in this question. Negative c is negative pi over 5 over b. What's b in this question? 1 over 2. And if you want help on how to do that, take the top one, write it first. Take the bottom one and get the reciprocal, like I did earlier. Means our answer is 2 pi over 5. All right, so if you want phase angle, just says find displacement. Displacement's negative c over b by the formula, and put it in. The trickiest part of this is the algebra, so make sure you practice this, okay? There's nothing I can do for you now besides just tell you to practice it. If you're struggling with the algebra, practice it and then ask me what you need. There's no way I can read your mind, okay? All right, that's enough for today. I'll stop the recording here. See you, everybody. See you next time.